Okay, alright. Bismillahirrahmanirrahim. Assalamualaikum and hi. So today I would like to share, I would like to explain, I would like to present how to solve this question, which is FET DC analysis. What is FET? FET is stand for Field Effect Transistor, FET. Alright, so before we start, let we read the question first. Okay, the question 1. The DC parameter of N-channel D-MOSFET. D-MOSFET is shown in figure Q1. This figure. By using graphical method, determine the following. Let's see the question number 1. Find the drain current IDQ. The second one, the DC gate source voltage VGSQ. 3. The drain source voltage VDSQ, and the last one is find the terminal voltage Vs and Vd. So from this question, given the formula ID is equal to IDSS 1 minus VGS over Vp square. So how to find all these questions? Relax. Let's find the question number 1 first. Find IDQ. So how to find IDQ? So the step number 1, to find drain current IDQ, the first step is construct transfer curve table. So like this one, the transfer curve table contain VGS and ID. So how to find the value of VGS and how to find the value of ID here? By referring to the formula given, ID is equal to IDSS 1 minus VGS over Vp square. So from the formula given, just enter the value given, like IDSS is already given in the equation, IDSS here, and also Vp is already given, negative 3 volt here. Next, how to find the value of VGS? To enter the value of VGS here, let's see the value of Vp first. So the value of Vp is negative 3 volt. Therefore, the VGS we set to negative 3 here until 0. So after done, enter all this value. By using calculator, just find the value of ID. So the value of ID when VGS is equal to negative 3 volt, the ID is 0, when negative 2, 0.7, negative 1, 2.7, and 0 is the ID is 6. So after done, construct this table. Let's go to another step, which is draw the transfer curve graph. So this is the graph that we enter from the value that we obtain from the transfer curve table. So from this table, just draw one graph of transfer curve like this one. So the transfer curve graph will become ID versus VGS. So after done plot the graph, just connect all the plot and will obtain this curve. So after done, this step 2, which is draw the transfer curve graph, let's go to another step, step 3. So for step number 3, by using KVL, Kirchhoff voltage law, we need to find the value of VGS. Alright, so during DC analysis, all of the capacitor will open circuited. So from this figure, there is 3 capacitor that will open circuit, which is this capacitor, and this one. Okay, so after all the capacitor open circuited, the new figure obtained is like this one. So how to obtain this figure? The way is, we need to find the RTH and VTH value on the figure question, which is this one. RTH will become 10 mega parallel with 110 mega ohm, and the value will become 9.167 mega ohm. And to find the VTH value, 10 mega ohm over 10 mega ohm plus 110 mega ohm times with 20 volts. So how to know this value? The 10 mega ohm will be chosen is because this resistor is connected to the ground. So the value of VTH obtained is 1.667 volts. So from these two values, construct this figure and find the KVL to find VGS. So where is the VGS? VGS will add here, VGS. So from this figure, do the KVL and from ground to ground. So from this figure, ground to ground, and then do the KVL, which is the first one is negative 1.66 volt plus 9.167 mega Ig. Here is Ig plus VGS plus 750 Is. Here is Is and equal to 0. And the important thing in FET that we must to know is the general relationship for all FET, Is is equal to Id and Ig is equal to 0 ampere. So after then, VGS is equal to 1.667 minus 750 ID. So after you obtain the VGS value, so for what? This VGS value, we go to another step, which is step 4, construct linear graph table. And this is the linear graph table based on the KVL before. By referring to this equation, VGS equal to 1.667 minus 750 ID. So, from this equation, how to find the value of VGS? So, the value of ID we will obtain from the graph before. So, from this graph, we just choose 3 or 4 points of ID that we will enter in the table. So in this case, I choose the value of 3 milliampere, 5 milliampere, 7 and 9 milliampere. And then after we enter it on the equation and this table, to find the value of VGS, 1.667 minus 750 ID and enter the number of ID. This one, 3, 5, 7, 9. So just by using the calculator, enter this equation and the value of VGS will obtain negative 0.6, negative 2.1, negative 3.6 and negative 5.1. So next, what we need to do from this table? Let's go to the graph and we will construct the linear line. Okay, so next, by referring to the table before, the value of ID 3 and the VGS will negative 0.6. That, like you can see here, when ID is equal to 3, the value of VGS is equal to negative 0.6 here. And when ID 5, the value of VGS is negative 2.1. When ID 7, the value of VGS is negative 3.6. And when ID 9, the value of VGS will become negative 5.1 here. After plot all these points and then just connect all this plot and you will obtain this linear line. So next, how to find the value of IDQ and the value of VGSQ by referring to this graph. So from this graph obtained, the value of IDQ and VGSQ we will obtain from this overlap line, this clash line. So from this line, we will get the value of IDQ here, which is 3.26 milliampere, and the value of VGSQ here is negative 0.79. So the value of IDQ and VGSQ is not same for all. The value of IDQ and VGSQ is by referring to the graph, which is how the student connect all this plot. So until this step, we already done the question number 1 and question number 2, which is to find IDQ and also VGSQ. Okay, next, so to find the DC drain source voltage is we just use back the figure before that already simplified the RTH and VTH here, and we just need to do a KVL, Kirchhoff voltage law, at here to find VDS here. VDS. So to do the KVL at ground to ground here, and the KVL will become like this. Negative 20 volts plus 1.8 K ID, here is ID, and plus VDS plus 750 IS, here is IS. So like before, IS is equal to ID and IG is equal to 0 ampere. And the equation will become VDS is equal to 20 minus 1.8 K ID minus 750 ID. Okay, so where to find the value of ID? The value of ID, we will use the value before, which is the value at the graph, the IDQ value, which is here 3.26 milliampere. So, and then we just enter the value of ID here, and we will obtain the value of VDS Q is equal to 11.687 volts. And then we already done the question number 3, which is to find the drain source voltage VDSQ. And then let's go to the last question, which is question number 4, to find the terminal voltage Vs and Vd. So the simple step that we will do is we just need to find the value of Vd. How? So the next one, to find the value of Vd, we just put one node here, which is the node for Vd here. And then we just do a KVL from ground to ground here. And the KVL will become negative 20 volts plus 1.8 K ID plus Vd. And Vd is equal to 20 minus 1.8 K ID. And the ID, we will use the value before, which is 3.26 milliampere. And the Vd value will get 14.132 volts, value of Vd. So we done find the value of Vd, and how to find the value of Vs. The value of Vs by using this equation, Vds is equal to Vd minus Vs. And we just enter the value of Vds and Vd, and Vs will become Vd minus Vds. So the value of Vs will obtain 2.445 volts. So we already done to find the value of Vs. So that's all from me. But before that, remember that the value of IDQ and the value of VGSQ is not same for every student. The value for IDQ and VGSQ is by referring to the plot graph that every student will obtain the difference, maybe plus minus 0.1, the value of IDQ and the VGSQ. So just that from me. Thank you. Assalamualaikum.